Awesome. So great. Thank you for the time and excited. So today, I think that everybody of us wants for Ethereum to scale and wants to reach its goal of mass adoption. However, my thesis is that we won't be able to do that unless we change the ways we interact with Ethereum. So we want Ethereum to be scalable, private, but also secure. And how I think about this is that private keys and the ways we do it right now doesn't cut it. My thesis, where I will develop here, is that there are many other ways that we can unlock, and we will do that by getting into the intersection of account abstraction, zero knowledge, and what we call like existing digital infrastructure, which is basically everything that we use day to day. All right, so let's get on it. Very basic, how do we interact with Ethereum today? Simply, we create like a public-private key, and my public key is the way you recognize that I control an address. And whenever I make a transaction, I make a signature. Now, we're going to get a bit technical here. The way we make these signatures is a very specific way called ECDSA, on a very specific elliptic curve, which is called SecP256K1. This is awesome, right? This is just like nerdy words. The thing is, this is the way that Ethereum works, and we have inherited some of this from Bitcoin. However, this is not how the rest of the world works. And this in itself, we have some problems. And we have heard them across the last days in terms of like wallets, account abstraction. I'm going to mention them briefly, and then we're going to jump into some of the projects trying to achieve these and what I've seen a direction from the ecosystem to grow. So what are the problems of private keys or externally owned accounts? This is a single point of failure. That means you get hacked, you get stolen that private key, and it's gone. There's no way to recover it. You forgot about it, it's gone. Did you know that 20% or 1/5 of all the Bitcoins have been lost in private keys? That's not what we want to do with Ethereum. We want to have a much, much better user experience. All right. Other problems, it's very hard to remember. So how many of us do we remember like all the digits of a private keys or even the seed phrase? Actually, do we remember them? Do you trust to remember that 50 years from now? And another problem that is usually not mentioned is that it's a limited scope. So usually these ways to interact with Ethereum, we don't use the same private keys to interact with the rest of the world. And that means that we sometimes forget to take care of this, we forget where it is, etc. This is not the way that we're going to scale Ethereum and get mass adoption. In summary, this is a terrible, terrible user experience. Barry was mentioning that, but also tied to what Vitalik mentioned yesterday. This is a bad, bad user security because users are not able to control their funds or their access to Ethereum in a long process. So what if there was a better way to interact with Ethereum in ways that we are already used to do with the rest of the digital world? And this is the direction that I think we should be going as an ecosystem. There are so many ways of interacting with the digital world with different digital signature schemes, different protocols, different curves that are not natively supported on Ethereum. And I think we should do that. So if you were to take one idea from this presentation is this. I think we need more people working in the intersection between account abstraction and wallets, in the intersection within zero knowledge space, and just looking outwards into what I called external digital signatures, which basically is all the digital signatures that exist outside of Ethereum, all the digital infrastructure that exists on our Web 2 world. All right, so right now we say I mostly approve my transactions with my private key, but what if we grow this into an infinite ways to approve transactions? And we're already seeing the ecosystem going that way, especially with account abstraction. So yeah, what if I could approve my transactions with my phone, with a tapping, with my biometrics? What if I could do just text message? What if I could do my just passport or my government ID that I carry with me? Or what if I could have a sticker that I just put some RFID there, and that allows me to approve transactions, or scratch pads, or emails, or laptops, iPads, etc. Like there's just a plethora, like a huge amount of data or digital signatures that exist on Web 2 that we could use them basically to interact with Ethereum. And the advantage of these is that people are already interacting with the digital world daily with this. So we don't need to teach them a new way to interact with Ethereum or with Web3. We just need to onboard these signatures towards Ethereum. So why is this cool? Because I believe that this solves the two fundamental adoption problems for Ethereum. One is the user experience. So as I was saying, people are already familiarized with these other onboarding tools, with other ways to interact with Web2. So we should go towards the users, not have them teach all this crypto jargon and all these new ways in which we suggest to interact with. It's very familiar, it's a simple language, and already billions of users are using this daily. And the other problem is, like, again, user security. There'll be no people forgetting their private key. There will be no people needing, maybe in some of these interactions, you won't even need to install a wallet or an app to interact with Ethereum. All right, so why this hasn't been done before, or why is this possible now? Well, actually, I think there are three reasons. There are three friends that have converged together into unlocking these innovations. One is account abstraction. I know, it's been years, we've been talking about this, and maybe with different names, and now we have EAP4357, and it's super needed, but I feel like, okay, I think we're still need more interoperability, but we're going towards the right direction. We need to abstract away the complexity with different wallet implementations, different ways to handle verifications on Ethereum. The other is layer 2s. So layer 2s have basically make possible to do a lot of like expensive computation a lot cheaper on Ethereum. And we do that because of the properties of layer 2s. And that makes something that before we could only do with Solidity, costing millions of gas, so basically a transaction that costs hundreds of dollars, now with layer 2s makes it a lot cheaper. Now, does that cut it? I think that's enough for many of the interactions, but I think the next generation of interactions are actually going to need CK. So CK, what allows you is to make a lot of these proofs and all of these ways we interact with Ethereum a lot cheaper and even a lot private. So the convergence of these innovations, I feel, is what's going to unlock the next generation of ways to interact with Ethereum. So now, in this second part, I'm just going to mention a few projects and how I think or see these projects being used as a way to approve transactions or interact with Ethereum. One column or group of projects, let's say, are going to come from the government IDs. Surprisingly, without their need, they're going to help us. Another is going to be biometrics, and another one is going to be email. And the last one I just call the existing systems. And if you were in Barry's talk, actually, we're going to leverage some of the same examples as we're working on the same PSE group. But hopefully I dive into some details that he didn't mention or just rephrase some of the things if they weren't clear the first time. So government IDs. Many countries around the world use a digital ID that you can prove certain facts about yourself. Sometimes they do have a physical form, and sometimes they also have a digital form. So one program that is super interesting is in India, the Aadhaar card program. It actually is the biggest digital ID program in the world, with 1.2 billion people use it, and they use it every day. They use it to get loan agreements, they use it to do house applications, they use it to interact and sign stuff online. So people are already using these daily. What if we could use the digital, the Aadhaar cards, as a way to approve transaction on Ethereum or to prove any specific thing? So on PSE, we have a project called Anon Aadhaar, which allows you to do local generation of zero knowledge proofs for a wide range of data on your Aadhaar card. What this allows you to do is to prove that you're an Indian citizen, and eventually what we want to do is like you prove that you are an Indian citizen that controls this account without saying who you are. So right now, what type of usage do we get with this? Well, it's a very simple anti-Sybil mechanism and very strong. It's privacy preservative. It allows you to airdrop directly to Indian citizens. It allows you to host quadratic voting or quadratic funding. It allows you to do KYC, et cetera, et cetera. Now, what's the road ahead for this project? The version 1 is what we currently have, which is something very experimental, built on a language called Circom and a proof system that is very good, but it's not as performant. So right now on a laptop, it takes you 10 minutes. That's not what we want. In version 2, what we want to is focus on performance, which means that you can do these proofs very easily on your laptop or even eventually on your phone and very cheaply. Now, the future of this ecosystem of government IDs is leveraging all the government IDs in the world, again, to interact with Ethereum. So the other next targets could be Indonesia, China, Mexico, Bangladesh, and many more. It's basically this same digital construction, and what Barry was saying with RSA signatures, many countries have a very similar construction. Now, I even heard the government of Palau has already an on-chain identity. And even heard that there are some teams looking into the European Union digital program. So maybe, I don't know, this year we will see some other projects like that. If you want to try it, feel free to do it. The second pillar that I was mentioning is biometrics. So what's something that you carry on with you every day and that you won't forget about it? Well, your face. Your face, your fingerprints. So there are already 6.8 billion smartphones in the world. It's estimated that 80% of them support biometrics. So quick math, there's 5.4 billion potential hardware wallets that are usable just with biometrics. We, as a society, have got used to just unlocking our phone with our Touch ID, with our Face ID. What if we came to the users without needing to install anything and just like approve transactions for them with this? For this, there's a growing landscape and configurations of projects on how to approach this. There are pure Solidity path, there are pure CK path, there are elements that use like Apple's Secure Enclave or Android's keychain or many other web auth like abstraction layers to synchronize them. But I think the goal of this or the gist of this is, again, we want to make it easy for users that are already used to authenticate with their biometrics and approve transactions with this. These are some teams that have been building this, so a quick shout out. And I think there are, again, more teams in the ecosystem that we want to push towards approaching this problem. The third way in which we're going to interact with Ethereum in the future is with emails. And there's a growing ecosystem as well on the email front. There are 348 billion emails sent daily. What if we could capture some of those? What if we could use some of those emails as a way to send and receive money? Even my grandma, who is like over 70 years old, uses email on a week-to-week basis. And we could onboard her to crypto by enabling interactions in this platform, in this UI. So some projects that I'm excited that are around the PSC, 0xPark, CK ecosystem is like proof of email. Allows you to take an email and make a proof about its content. So one demo that they have built is proof that you own or control a Twitter account. And this is the basis really to build more and more complex applications. By the way, all what I've talked on this talk is like open source, open, and we just want to have more people building applications on top of this. A really cool new one as well that is starting, Barry referred to this a few hours ago, is email wallet. What if I just send an email to you saying I'm transferring 1 ETH to you, and you don't have to do anything. You don't have to know crypto. You don't have to download a wallet. You don't have to set up a private key. It just gets to you. And how do you spend it, you might ask? Well, you just send another email to somebody else. And how does this work? Well, basically, emails are signed. Everything that has a private and public key could be potentially onboarded to Ethereum as a way to interact with Ethereum. Emails are no different. And this project is super excited. Again, it's an experimental growing development phase, but I think it will be really, really cool, primitive for the rest of the ecosystem to experiment with. And lastly, the CK-P2P, trustless on and off ramp. We're saying that, Barry, again, like a few hours ago, you can make a proof that you transact some money over Venmo to somebody. Venmo sends you an email, and with that, you can unlock the funds on-chain. This is a very simple idea, but very powerful way to avoid what we call like choke points on crypto. This is key because right now, on-ramps and off-ramps are one of the main choke points for crypto, and the other one is like Apple Store, Google Store. But with this, there's actually no need to install anything. There's no need for Venmo or PayPal or MoneyGram or any other payment processor to do any change. We're just leveraging the emails that they sent, and we're making proofs about them, and that allows us to use it trustlessly as an on-ramp and off-ramp. How cool is that? And the last idea, which again, really crazy, Barry mentioned it, is the GitHub wallet. So very simply, whenever you interact on GitHub, you could sign a commit. And that signature basically could be leveraged as a way to approve transactions. So what if I say I want to onboard, I don't know, like this group of developers on this repository because they're super awesome. I want to onboard them to Ethereum. Well, I would just send them money through GitHub Wallet. How do I send them money? Just tag the GitHub Wallet bot. And that will send 0.1 ETH from your smart contract wallet to Bob. Now, how does the GitHub Wallet knows that it's actually you? Is because your commit or your pull request, it's signed by your signature, and we can verify it, and your smart contract wallet could be configured to only operate or transact when you sign this. Cool. So making a summary, getting to the end of the presentation, why is this important? Because we're solving two of the major problems for Ethereum, which is user experience and user security. And we're doing that by hijacking or more leveraging or harnessing all the digital infrastructure that exists in the world. Why is this possible? It's possible because there's right now a convergence, and I don't think there's many people there, but I think we're getting into a kind of abstraction, zero knowledge, and just looking into the ecosystem and the ways that people are used to interact with the digital world. What's the next step here in this area? I think let's expand our sources. I mentioned 4 ideas, 4 pillars, and I think there's a lot more yet to be discovered. Let's expand the composability. What if I could say send a $1,000 transaction, but I would need to approve it on GitHub and on email and with biometrics? Okay, let's try to compose those proofs very easily and make it developers, and let's build apps so that it's very easy and interoperable to use across the ecosystem. And lastly, let's explore novel flows. This is a call to all application developers to start thinking about these primitives and how, after they get to a production level, you can start building cool, interesting, innovative flows. Awesome. Thank you very much.